You want to get the right things done for your security program. Sounds simple, but what are the right things for you? What does done mean? And how are you going to get there? Rapid7 realizes more than anyone how hard this can be. While Rapid7's Insight platform offers you industry-leading vulnerability management and detection and response solutions, their focus is on understanding where you are so that they can help you get where you're going. Visit securityweekly.com/Rapid7 to get started. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Welcome back, everyone, to Enterprise Security Weekly. B-Sides Boston is back in action for their 10-year anniversary. The conference will be held this Saturday, September 26th. Tickets are only $10. bsidesbos.org. Get yours today and check out Security Weekly, as we'll have our own channel in the B-Sides Boston Discord server, answering questions and possibly doing some contests. Jeff Capone is the CEO and co-founder of Secure Circle, and here with us today. Jeff, welcome.
Thank you for having me.
Peter Levett is the Chief of Staff at Secure Circle. He's with us today as well. Peter, welcome.
Thank you also.
I've been toying with this first question in my brain for some time, and because I really love how it challenges our way of thinking, right? And so the first question is, when we talk about zero trust, how do we achieve zero trust when we have to trust our users with our data or other people with our data? Zero trust implies there is no trust, but yet we do have some trust in our users inherently in many of the situations we're in today.
Yeah, no, I mean, one of the things that you notice, zero trust is a very popular security architecture that's being adopted. It's about 10 years old, I think, as everyone knows, that was proposed about 10 years ago, but now it's, I think with the cloud becoming the good guy rather than the bad guy. I mean, I think we talked about this at one point in time. At one point, not too long ago, the cloud was the bad guy, and you were trying to protect your data that would be exfiltrated to the cloud. But now the cloud's the good guy, and you're trying to protect your data in the cloud from leaving. And so the zero trust model, I really got a lot of attention once the cloud became the good guy. And the idea, as I'm sure all the viewers know, it's really about isolating and controlling the users, controlling the device, controlling the network, controlling access to the various workloads. And because when you talk about zero trust, that means no trust. And what does it mean? If you don't trust someone, you have to always be in control. If you don't have control, then you're assuming trust. And so to truly have a zero trust model, you have to be in control of every aspect of your network, of your devices, of your users, and also of your data. So you see a lot of vendors coming out now talking about zero trust data or zero trust for data. And if you really look at what we're trying to do by putting controls in place to control the user, control the device, control the network, these are really all proxies for controlling access to the data.
Matt, sorry. Sorry, Jeff.
Sorry.
Continue. Oh, Matt had a question.
Yeah, and I was going to say, Jeff, I mean, we saw the early zero trust vendors come out and really go after the network, right? And they said, look, we can create zero trust through the network layer. But we've abstracted the network away in a lot of places. And so I've always talked about my triad, right? Applications, users, and data. And I think what's interesting and unique about the zero trust model that you guys have really started to build out is you're taking aspects of users, applications, and data in a way that really brings that triad home. For me is I can't have full trust in any one of those three components. It's a combination of those three and how they interact.
And it is. And if you don't truly have control over all those aspects, you can never truly achieve zero trust. So you really need to apply all your access controls all the way down to the data itself. You can't rely on, I mean, just a simple example. If you just think of access controls on an S3 bucket, if the access controls are on the bucket, which they are, and you move an object from one bucket to another, the ACLs don't follow the data. So if somebody accidentally moves an object and it goes into a non-CCPA bucket and it happens to be CCPA data, then they have a problem on their hands potentially. So, or better yet, someone moves an object from a top secret bucket to a public bucket accidentally. And since the access control is about the device holding the data, not the data itself, you've just created a huge security problem for yourself. So to truly have true zero trust, you have to not only control who has access at the device level or the fabric, so to speak, that's storing the data, but also the data itself. And that needs to be persistent with the data, no matter how the data moves. Otherwise, at some point, you're going to be in a situation where you don't have control over your data. And that means you can never truly have a zero trust model in place.
Yeah, and it's interesting. I like Jeff and Peter both the way you described this on our webcast too. That discovering where it is and tagging it is really just that. It doesn't really help protect it, right? Because in your example, I know it's in a top secret bucket, and maybe I've tagged it as that, but then someone moved it, right? Like that, so I can discover and classify all I want, but it's not helping me protect it.
Right. I mean, one of the funny things we talk about internally. Honestly, half the team used to build storage most of their career. And at one point in time, data protection meant backup, right?
Right.
And one of the things when people backed up, just take endpoints or any really storage location, when you backed up, you didn't select and discover and classify what you backed up. You just backed up everything, right? Because you don't know what could be important at some point in time. So to protect all the data, when protection meant backup, you really just backed up everything because it just didn't impact with the user experience, right? You didn't have to go through this classification and figure out what you're going to truly back up, because that's the real important stuff. If we lose it, just backed all of it up. Same principles apply for when data protection means data security. Really should just protect it all, because you don't know what's going to be important. Something that you might not think is important today could be important tomorrow. Things that are important today might not be important tomorrow. For example, your quarterly earnings report. It might be very important today, but once that becomes public information, it's no longer important. So the state data is in, so to speak, is changing all the time. And there's no way rules can keep up with that. So you can't go and constantly have ways to hunt that down and change the different classification that the data is trying to adopt over time. It's a much better approach to just protect it all, just like we did when data protection meant backup.
Yeah. I mean, nirvana use case, right? If I protect all the data, then it doesn't matter where the data lives. If you don't have access or the keys to get to it, it doesn't matter, right? It's like the nirvana use case for security in general. If I just protect the data, then it doesn't matter if a hacker gets it. They can't do anything with it because they can't read it.
That's correct. So the idea is when you protect the data, encryption is the means of protection, but you can't ever decrypt for example, if you're encrypting a file to protect it, you can't decrypt the file. You have to be able to read the encrypted file without decrypting the file, but allow applications and users of those applications to read the data without, for example, decrypting a file. And that's possible. You can do that, and we've achieved that as well. But that's the important bit, because if you just did a mass decryption, or if you gave someone the password as mentioned before, or the key, then you've lost control. So the trick is allow people to access without giving up control. That's the key to zero trust, because once you give up control, and then you've lost your zero trust model.
And I love the technical aspect of this, and maybe at a high level explain to our audience your interaction with the file system and how that helps you achieve this in Secure Circle.
Yeah, so essentially we look like an encrypting file system to an application, or in other words, a file system to an application or process trying to read data. So, for example, would an application be aware that the blocks on a piece of media are encrypted when it's making a request to read bytes or a byte range? It wouldn't. It just reads those byte ranges. Into the technical details how that all works, but essentially it passes a file descriptor to the operating system and requests a byte range to read, and it gets it back, right? And that's all an application should worry about. I mean, if you really think about it, security shouldn't be a concern of the application. It should be the concern of the owner of the data. So if I want to access something, I should just access it as I normally should if I am trusted. And I should be able to access it and yet never given control. The owner of the data or the service is the one that has to worry about security and worry about maintaining control. But it shouldn't be the burden of the user of the data to really worry about security. In fact, I think you had a really good series or episode on passwords, right? I mean, passwords, I don't want to say they're a joke, but passwords are going to be antiquated. We all know that, right? Really, I should just walk up. My face maybe is my ID or whatever happens to be, but I shouldn't feel like I have to go and deal with anything cumbersome to get my job done, whether it's a physical job, whether it's a digital job. It should just be transparent to what I do. I should just be focused on doing my job. And really, truly with Zero Trust, as long as you line up everything and always have control, you can achieve that as well in the digital world.
Well, that's a great point, Jeff. It's reminding me of the challenges, right? That, like using PGP, for example. And, my friends and I would try to keep things secret. Not only we had to manage the data, we had to manage the encryption process, we had to manage our keys, and then the passphrases for those keys, right? And that's trusting the users way too much, I think.
It is, right. And you shouldn't burden the users either with security. I mean, really, once you burden the user with security, they just try to find ways around it. The real trick to achieve security is not to put up roadblocks to users that they try to get around. Maintain security without having them realize it's even there.
Right.
And that's the whole idea with passwords too, right? I mean, and that other episode you had, right? It's how do we fix that problem?
Yeah, and I think Peter had a demo to.
Yeah, so one of the things that before we jump over to Peter, one of the litmus tests we like to talk about internally when it comes to Zero Trust data is what's the piece of data that's the most fluid, that is really valuable to an organization, that we can protect and always still maintain control, right? And we say internally, if you can do that with source code, then anything else is trivial, because source code is valuable. You have high earners working with that data that you don't want to bring down. They don't want to have barriers put up in front of them. So if you can truly deliver a zero trust data model for source code, then you've won, right? So what Peter's going to show in a moment is how we deliver zero trust for source code, and show you that a developer wouldn't even realize that anything's changed. They'll do their job as they normally did, yet the organization who owns that source code has complete control all the time. They can enable the developer to do their job without giving up control over that data.
Right. And it's important too, I think some of our listeners may be like, well, my source code's open source, right? There's lots of different source code out there. It was when I was reading Countdown to Zero Day, they went into great detail as to how, look at source code that's highly sensitive, such as the software that runs the routers that pass most of the traffic through the internet, right? That is some of the most closely guarded software on the planet, and for good reason, right? And so there's everything from open source to, that use case, but source code needs to be protected, and it depends on the organization. But obviously, in that use case, super important.
Correct. Yeah. Thanks for that point.
Peter, over to you for the source code demo. I don't know if Peter, are you on mute? I saw your mouth move. I didn't hear anything. I just want to make sure Peter's not.
My apologies. Can you see that
there
okay?
you go. Yes, thank you.
Yes.
Yeah, so as Jeff said, a really strong use case for us, and customers come to us and say, "This is if you can solve this, we'll be happy," right? And of course, we have many different use cases that we can protect data, but this is a big one for a few reasons. And like Jeff said, because the data is very valuable, because customers have lots of different data types, file types that they need to protect. A lot of simple file types that don't have inherent security built into them. And they have developers that just want to get on with their job, right? So in the demo I'm about to show, you'll see I've got a GitLab repository set up. And what we're going to do is we're going to see the process or the flow of data and how we secure it throughout that flow. I have a very simple environment. I'm a single developer in a single circle is what we call it, right? And I have access to this GitLab environment where I can pull the source code down to my device, do my job, access the source code, but the whole time the source code will be secure, and I'll show you every step of that journey.
But Peter, just clarity before you go there. This doesn't have to be one developer. You can have a circle around lots of developers in the case where you're distributing the source code for different developers to work on. Same concept applies, right?
You got it. I just like to greatly simplify the demo. Of course, this is intended that you would have, as many developers as you need, all a part of as many circles as you want to protect different projects and what have you, right? This is just a simple environment. So here's our console where I've just configured myself as part of the one secure circle environment. In the real world, you'll have a lot more users than just one, of course. And just quickly to show you, here's my GitLab, here's my source code. This is the repository that we're going to pull down and protect as the sample source code for this particular demo, right? If I go over here, I've got a Windows machine. This is the developer's operating system. It's running the Secure Circle agent. There's nothing on it yet, so this is a really bare bones setup. I've got Visual Studio Code. That is going to be my allowed IDE. I could have many allowed IDEs. In this case, I've just got one. And it's going to be able to access the data even whilst it's encrypted. It's important to understand we actually never decrypt the data. It's still encrypted even in use. But in this case, there's nothing yet on this device except for one file. So I have one file here, which is a private SSH key, which is what I'm going to use to access the source code repository. And in this case, this is the one and only file which is already protected by Secure Circle on the device. So what does that mean? Well, that means I'm an allowed user. I can access this file, but only with processes that I've been allowed to use it with. So in this case, Git is going to be able to use this private key and access the contents of this private key file to clone my repository, to pull my repository down, right? Whereas if I tried to open it in an unsanctioned process, so a really good example is Notepad, right? I'm not going to be able to see the contents of that file and therefore get that key. So what we'll do now is I'll open up my IDE and I'll clone the repository, and you'll see how that happens, right? Let me just bring this up here. So I'm going to do a clone using Git. I'm going to pull down the source code. You can see it's pulled the source code down. You can see that's appeared in my IDE. You can see here it is on my local file system. And what you'll see is we're protecting all this content. Now, the IDE can access all of these files regardless of file type, right? As all my code, I can do my job. I've got a little code snippet here that I've created that I can run. And you can see that process can run, right? So I can do my job. I could compile if I needed to. I can do everything here. Now, if I attempt to open this, once again, in an unsanctioned application, so even the README, I'll open with Notepad. You can see I can't access that data. If I create a text file on the desktop here, and I go to take some of this code. So let's go and grab this Python function here. I'll copy this. You can see I've not been allowed to move the content of that code from the allowed application to what we consider a disallowed application. If I go and take another route, well, my IDE is an allowed application, right? So what if I open the text file in my IDE? Well, that's fine. I can paste into my IDE just fine. And if you look at the file, when I go to save the file, at that point, Secure Circle has protected this derivative because it has contents that we recognize from the original file through the allowed application. If I try and open that now in Notepad, sorry, I'm just going to move this. Once again, the data is fully protected. Does that make sense?
Oh yeah.
Absolutely.
And so what about we decide Peter Levett's no longer going to be a member of the development team, which is probably a good thing. We'll go in here and we'll disable his account and remove him from the circle. Really, all we're doing at that point is saying all the processes that were allowed on Peter's device, they're no longer allowed. No processes are allowed at this point. So if I go and go to open the IDE again, you're going to see I'm going to get errors as I try and read content that has already been secured by Secure Circle. In some cases, makes it a little bit tricky to open the IDE, but in most cases, it just stops us from accessing the data. So you'll see.
So not only do you have data level control, but you also have some level of application control here as well, right? Maybe this developer, if they left the company, it's easy to shut this down, even though the ID might have been loaded somewhere else. Or if they change roles and they move to a different group, maybe they don't need access to some of those applications and or files anymore, right?
Yeah, that's totally true. We don't intend to. I can use this application for other means, but the idea is we've denied this application access to the data. So there is some process level intelligence or application level intelligence in that you get to define which applications are allowed to access data and when, and you get to define which applications are producers of data you want to secure and how to identify that, right? So there is application level control involved here. In order to access data, you need to be an allowed user on an allowed device with an allowed process. All three things need to be true. In this case, that's no longer the case. I'm no longer a allowed user. None of my processes are allowed. I just can't access this data anymore. So, and
one of the interesting things, Peter, that I just wanted to point out in your demo is that we gave out the key, the SSH key in this example, but the SSH key itself was protected so that you truly never gave up control when you gave up that key. So I want to make sure that people say, oh, he just contradicted himself. You guys just issued an SSH key and gave up control. No, we never gave up control because that key was protected by Secure Circle. So access to that key can be pulled back at any time. So as you saw, once Peter tried to open the IDE, he couldn't authenticate. So he couldn't even authenticate to his GitHub repository because he couldn't actually even read the key that he even possessed.
So let me just show that, right? So let's say I realize I can't get to this data anymore through my IDE. And to Jeff's point, well, I could just pull down another copy of all this code, right? Okay, this code's protected. Then what if I just delete this clone and create another one? And this is exactly to Jeff's point. If I go and do a clone now, watch what happens. At this point, I'm getting denied to even clone from the repository. And why is that? Because the private key that you saw that I had protected previously, that Notepad couldn't open, but Git can't now be opened by anything on this machine. So I'm now getting permissions denied to even attempt the repository.
Which means
so we gave out the key, but still didn't give up control.
Right.
We lent you access to the key.
Right.
Right.
I love it. It's
and
awesome.
now
you had a lease and the lease expired.
Yep.
Right. Right. And I would say if I was a developer, you would definitely remove that key. So that's it. So hopefully that shows you sort of the journey that we went through, right? the developer had the ability to clone to their device. Git was an allowed process. It could access that key, could pull the code down. The developer could use that code, do their job, copy and paste between allowed processes and applications, but not outside of allowed processes and applications. And ultimately, we could pull control back, which is kind of this last step of the journey. You try and attempt the data on any device that isn't allowed, with any process that isn't allowed, or by any user that isn't allowed. You're just not going to be able to do it.
And it really puts those safeguards, for lack of a better term, around that application, right? So I can't print it, copy and paste it, inject into that process and try and get it out. Like, I can't get it out of that. If I get it out of that process, it's going to be encrypted, right?
Right. The way we talk about it is we're really securing the flow here. And if you think about like this shared security model of cloud, cloud vendors secure the cloud and you secure what's in the cloud. What we're really doing is extending that security model so we can keep securing the data as it leaves these structured locations.
Yep.
That's awesome. Any other closing thoughts from Jeff or Peter?
No, I think we illustrated that source code again is just one example, and that's an extreme example. And one of the things I like to say when it comes to putting security measures in place, when you think about the customer base you're trying to address and their sensitivity to security tools, I put developers on the top of the pyramid and then executives underneath them. We find that executives are more tolerant to security tools than developers. And being successful with the developers just means everything else from there is gravy.
Yeah, no, it's a great point. We dug in a lot deeper, and our audience asked a series of awesome questions in our webcast with Secure Circle, which you can find on securityweekly.com/on-demand. That was titled "Why Traditional Data Security Can't Be Zero Trust." And our audience can find out more by visiting securityweekly.com/secure circle. Jeff and Peter, thank you very much for appearing on the show today.
Thank you.
Thank you very much.
That will conclude today's Enterprise Security Weekly. Thank you, everyone, for listening and watching. We'll see you next time.